So now I'm going to go through two more examples of how to factor these simple trinomials. So remember, trinomials, tri means three, so we have three terms. So we're looking to get something that breaks into two brackets like this. We have an x plus or minus a number and an x plus or minus another number. And these are called simple trinomials because their a value here is 1. This is the b value, this is the c value, and we'll talk about that a little more when we get into quadratic functions a little bit further. So I'm going to show you all three methods again, just like I did in the last video. So we're going to start with algebra tiles. So our question was y equals x squared minus 3x plus 2. So I need to start by getting those algebra tiles, and I need to put them into that rectangle shape. So here's my x squared. Now I have a negative 3x here, which means that I need 3 of these negative x tiles. And then I have a positive 2, so I need 2 of the positive 1s. So now I have x squared minus 3x plus 2. So I need to turn this into a rectangle. So if I start doing things like this, there we go. If I rotate it like this, then I get a rectangle. So I have x squared, and then minus x here, minus 2x is here, and a minus 1 here. So then I need to factor. Here, I'm always going to get an x with these simple trinomials. Later on in math, you'll see ones that are not simple, and it won't just be an x in the bracket here. It might have another number in front of that x, but in this course, this is all you need to know here. These will factor up to an x, and here, because this is negative, we have to factor out a negative 1. That's the greatest number we can factor out of these things. Here we have an x, and here we would have negative 2 because there are 2 negative rows here. So in our brackets, we get x minus 1 and x minus 2, like that. So I will very quickly draw these again. So we have x squared minus 3x, so we put one of them over here, and we had 2 of them down here, and then we had plus 2 like this. So when we factor that, we got x minus 1 and x minus 2. So we put that into the brackets, x minus 1 times x minus 2. So I'm going to show the same thing using the area model. So again, we take the x squared term and we put it in here. We take the constant that's at the end with no x's and we put it here. And then we need to break this into 2 pieces. One of the pieces will go here and one will go here. And we find those pieces by looking for 2 numbers that multiply together. So number times another number that equals this number, 2. And then another number, that same number plus this same number that equals this number right here that's in front of the x term, which is negative 3. So some factors of 2, well, we can multiply 1 times 2. So 1 times 2 is 2. But 1 plus 2 is not negative 3. So we have to think about how can we make this work? Well, remember that if we multiply negative numbers together, negative 1 times negative 2 will also give us an answer of positive 2. And if it's negative 1 and negative 2, so we need the same numbers, negative 1 plus negative 2 equals negative 3. So those are the numbers we're looking for, negative 1 and negative 2. Now remember, you don't have to write the one that's in front of the x. You can just write negative x. and negative 2x, but if it helps you, you can always write that 1 there. Then we need to find the greatest common factor in each column and each row. So here the greatest common factor is x. The same thing happens here. The greatest common factor here, this one has an x, this one does not. This has a negative 1 and this has a 2. Because this is negative, I want to make sure I factor in a negative number. And the only common factor here is a 1, because there's a 1 here and a 2 here. So there's no other numbers that I can divide out of 1 without getting decimals. Here I have 2 and 2, so that's easy to see that it will be 2. Because this x term is negative, I'm going to make this negative as well. So I will get x minus 1 times x minus 2. Always check this work by multiplying it back out using, again, algebra tiles, the area model, or FOIL. So x times x is x squared. X times negative 2, maybe I'll write this down actually. X times x is x squared. X times negative 2 is negative 2x. Negative 1 times x is negative x. And negative 1 times negative 2 is positive 2. When we collect these two like terms, negative 2x minus x is negative 3x, which gives us this, x squared minus 3x plus 2. So we know that these are the correct answer. I'm just going to go through the very last method, which when we talked about this in class earlier, it seemed like that was the common one that most people liked. But if you like one of the other methods, it's totally okay to use whichever method you want to use here. So the last method is basically this part of this method without drawing the boxes. You just need to come up with these numbers and then you just plop them into these brackets. So we know that when we factor a simple trinomial like this, we're going to get 2 brackets. And because this is simple, there's no a value here, it's just a 1. We'll get an x and an x in the brackets, and we need 2 numbers that go here and here. So we always multiply to this one that has no x's. So we need to multiply to 2. We need to add to negative 3, this one that has just an x with it. And then we need 2 numbers. So again, we need 2 numbers that multiply to 2 and add to negative 3. We've already done that work over here, so we know the numbers are negative 1 and negative 2. So we just plop those into our brackets, and then we're done. Then our final example, we have x squared minus 3x minus 10. So we'll go back to our algebra tiles here and get rid of all the previous work. So we had x squared minus 3x, 1, 2, 3, so there's minus 3x, or 3 negative x's, negative 3x, and then minus 10, so we're going to need 10 of these. And then I ran out, so I'll have to do this and flip 2 of them. And then I'll double check that I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. Turn this into a rectangle. And you may be noticing with 10 pieces and only 3 of these, it's not going to work right away. So I can put all 3 of these down here, like so. And I can start trying to make a rectangle with what's left. And very quickly I'm going to run into some problems because I can't make a rectangle with these. There's some things missing. No matter what I try here, I'm still going to get some missing pieces. And even if I rotate one of these and try to move it over here, I'm still going to have either extra pieces or missing pieces. So remember what I talked about before, where we have a positive and a negative that are the same thing, so the same variable, or if it's a 1 and a negative 1, the same letter, and they cancel each other out. So if I add these 2 things into my pile here to try to make this rectangle, I've essentially added 0. And if I add 0 to something, I haven't changed what I have, so that's totally okay. So if my equation I had was y equals x squared minus 3x minus 10, if I add 0 to that, nothing changes because I'm adding an x and I'm subtracting an x, which is just a 0. So I haven't actually changed the equation by doing that. So that is completely allowed. So then the key thing when you add things like this is that you can't just plop them anywhere you like. You can't have some negative x's and positive x's on the same side here. So if I have my negative x's here, I'm going to rotate my positive x so that it actually fits in this space up here instead. But you'll notice that's still not enough. I'm getting closer to a rectangle, but I still have some empty spaces no matter what I do with these extra ones. So I'm going to add another 0. So I'm going to add another one of these that will cancel with another one of these. So I'm adding 0. I'm going to put this one down here, and I'm going to rotate this one and put it over here. So now I've added 0 twice, and that's okay. I made a rectangle. And then I have to factor. So here we get an x, and here these are positive, so we get +2. Here we get x, and here these are all 5 of these are negative, so we get -5. So we get x + 2 times x minus 5. And if we check, multiply this out and check, and it will work. X times x is x squared. X times -5 is -5x. 2 times x is +2x, and 2 times -5 is -10. When I put these like terms together, when I collect these like terms, -5x plus 2x is -3x. So I'll have x squared minus 3x minus 10, which is what we had in the question here. So we know that this is correct. So I'm going to do the same thing with our area model. I'm going to put the x squared here and the -10 here. And then again, we need two numbers that when we multiply them together, we get this number, -10. And we need those same two numbers to add together to give us this number, which is -3. The negatives are really important. If you miss a negative, you're going to get the wrong numbers in these two boxes. So some factors of 10. Well, I can multiply 1 times 10 to get 10, but no matter what I do with positives and negatives here, I'm never going to add them together and get a 3. So that's out. Then I can multiply 2 times 5. 2 times 5 is going to be 10, and of course something will need to be negative to make it negative. And if I add these together, I either get 7. If they're both positive or both negative, I'd get -7. But if one is positive and one is negative, I can get a -3. So I need a 2 and a 5. And I need to make sure I have the right one negative. So if I try this, -2 times 5 is -10, so that works. But -2 plus 5 would be +3. But I need it to be -3, so I'll try it this way instead. 2 times -5 is -10. 2 plus -5 is -3. So these are the two numbers we need, 2 and -5. And don't forget, they both have to have an x beside them. Because what we're doing is we're splitting this into two pieces, just like we did with the algebra tiles. And in that case, we had to add some zeros, and that's okay. So we've added an extra bit here to make this work. Then we factor. Greatest common factor here is x. Greatest common factor here is 2, and it will be a +2 because this is positive. Greatest common factor here is x. Greatest common factor here will definitely be 5, because 5 times 1 is 5, 5 times 2 is 10. Negative, because this is negative. So I have x minus 5 and x plus 2. So I put those into the brackets. Don't forget that's plus 2. Plus 2. X minus 5, x plus 2. And that's what we got when we factored with the algebra tiles on that other screen. We ended up with, I think I wrote it the other way, x plus 2 times x minus 5. But, and we already checked that this is in fact correct. The last method is like this one, but with the box. We need to multiply to -10. We need to add to -3. And again, I would write this out again. So two numbers that multiply to -10. And we need those same two numbers to add to -3. We already figured out the numbers are 2 and -5. So we've gone through all of this work over here to get these two numbers. So we have -5 and 2. And then once we know that, we go x minus 5 and x plus 2.